Okay, let's dive right in. We're surrounded by numbers every single day, but what if I told you the ruler we're all using to measure the world is kind of wrong? Today we're talking about logarithmic scales, a sort of hidden ruler that completely changes how we see everything from earthquakes to the music you listen to.
So picture this. You're watching the news and you hear a 6.0 earthquake just hit a city. Pretty scary stuff. Then, just an hour later, the report comes in. A neighboring city was hit by a 7.0. Your first thought is probably, okay, that's 1 point worse. It just sounds a little bit stronger, right?
So let's really ask that question. How much more powerful is it really? Our brains are just naturally wired to think in straight lines. 1 + 1 = 2. So our gut reaction, our intuition, tells us it's just a little bit worse. But is it?
Well, this is where reality just completely shatters our intuition. That linear guess, it feels right, but it is wildly wrong. The shocking truth is that a 7.0 earthquake causes 10 times the amount of ground shaking. But wait, it gets even crazier. The actual energy it releases, a mind-blowing 32 times more. This is not a small step up. It's a giant, catastrophic leap to a whole different level of disaster.
So why is there such a massive disconnect? Well, it's because the Richter scale isn't a normal ruler. It's what we call a logarithmic scale, and it's a special kind of measuring stick designed to handle numbers that live in completely different universes of size. The one key thing to get your head around is this. On a logarithmic scale, each step up isn't adding, it's multiplying, and usually it's multiplying by a factor of 10. It's a system that's built to take these immense, sprawling ranges of data and sort of tame them so our brains can actually process what's going on. I absolutely love this way of putting it. It's a data compressor. Think about that. It's a mathematical trick that lets us take a tiny number, like 1, and a colossal number, like a billion, and stick them right next to each other on the same chart and have it all make perfect sense.
And this table just lays it out perfectly. On a normal, linear scale, you take 6 steps, you get to, 6. Big deal. But on a logarithmic scale, those exact same 6 steps take you from 1 all the way to 100,000. The growth is just absolutely explosive. It's not even in the same league.
But here's the part that gets really wild. This isn't just some abstract math concept for scientists. This is actually how you are biologically wired. It's how your senses perceive the world around you every single second.
This is such a fundamental insight into how we work. Think about light bulbs. The difference between a 10-watt bulb and a 20-watt bulb feels huge, right? The brightness literally doubled. But the difference between a 100-watt bulb and a 110-watt bulb, you'd barely notice. It's the same 10 watts, but our senses perceive the ratio, not the flat difference.
And this is exactly why so many things we measure in the real world use logarithmic scales. The decibel scale for sound, the pH scale that measures acidity, and of course the Richter scale for earthquakes. They're all designed to reflect this reality of how we actually perceive changes.
So let's just circle back to our earthquake one more time. This chart makes that energy difference impossible to ignore. That one little point jump on the scale doesn't mean one more unit of energy. No way. It means that magnitude 7.0 bar is more than 30 times bigger. It is a completely different class of event.
Okay, now for one of the most powerful, almost magical uses of log scales. How they let us take data that looks totally chaotic and unpredictable and use it to see into the future.
You've definitely seen these graphs before. When something goes viral or a company grows incredibly fast, you get this curve that just shoots for the moon. It's explosive, sure, but it's also incredibly difficult to look at that curve and have any real idea where it's going to be next week or next month.
But now for the magic trick, you take that exact same chaotic data, but instead of a normal chart, you plot it on what's called a semi-log graph. And that crazy accelerating curve, poof, it transforms into a simple, predictable, beautiful straight line.
So what does this mean? It means log scales can turn a super complex analytical problem into something as simple as grabbing a ruler and just extending a line. It makes forecasting, which can seem like some kind of dark art, incredibly straightforward and reliable.
So where does all this leave us? We've seen how log scales contain these enormous, out-of-control numbers, how they mirror the way our own senses work, and how they even help us predict what's coming next.
Ultimately, a logarithmic scale isn't just a math tool. It's really a new lens, a whole new way of looking at reality that lets you see the big picture. It lets you see the smallest tremor and the largest earthquake, all at once, and finally understand the true, staggering relationship between them.
And that really makes you wonder, doesn't it?
When you think about things like wealth inequality or the speed of technological growth, what other massive, important things about our world are we fundamentally misunderstanding, all because we're trying to use the wrong ruler?